7.1, evaluate and graph polynomials. So what we have learned up until this point has been graphing equations of lines, so linear, meaning like mx plus b, where the exponent is just to the first power. We've also learned how to graph quadratics, which is like an x squared function, but we have yet to learn how to graph anything greater than that, or any higher degree than x squared. So we are going to learn how to do that when you have like an x cubed, x to the fourth, x to the fifth, and you could keep going, keep going, keep going. We're going to learn how to graph those. So it's going to be fun. I love polynomials. One of my favorites. So a polynomial is a sum of monomial terms written like this. Don't let this function scare you. It's just saying like n is your highest degree. And it decreases in degrees from that. So it's going in descending order. Where a sub n does not equal 0. The exponents are all whole numbers. And the coefficients are all real numbers. So we don't have any imaginaries in this unit. Not yet. For this function, that's not right. For this function, a sub n is called the leading coefficient. Leading just means the first. N is the degree of the polynomial. And a sub 0 is the constant term. So it's just going to be a number. Just going to put a little number next to it. A polynomial is a standard form if its terms are written in descending order of exponents. So here are just some examples of vocab or words that I want you to be familiar with. So anytime you have a constant function, that means that it has no x value. So it's the same thing as saying, when you say degree, that's your highest exponent. So in this case, the highest degree for a constant is 0. It's like saying negative 14 x to the 0 power, which just becomes 1. So you have no x. Linear, my highest degree is to the first power. Quadratic, second power. Cubic, third power. Quartic, fourth power. And we don't really have words for the other ones. You would just say x to the fifth. The highest degree would be the fifth power, the sixth power, seventh power, etc. So there are a couple things that you have to look for whenever you're deciding if you have a polynomial or not, and they're up in the paragraph. So the exponents all have to be whole numbers. So when we get to the next section, we're looking for exponents, whole numbers. So that means you can't have like a fraction exponent or a negative exponent. The coefficients, what does a coefficient mean? The number in front. So coefficient, which is just the number in front of the highest degree. So in the linear one, 5 would be my coefficient, 2, negative 1, 1. So coefficients must be real. So we don't want any imaginaries. We don't want any, we just don't want any imaginaries, any imaginary numbers in there. And let's see. Those are the two things that we're looking for. So we scroll down. Determine if the following is a polynomial. If it is, write it in standard form, meaning I want to put it in descending order. State its degree, type, and leading coefficient. So if I look at number 1, are all of my exponents whole numbers? Like, do I have any fraction exponents? Nope, because I have a 4 and a 2. So we're good, and a 0. So that's good. Are my coefficients all real numbers? Meaning, like, do I have any imaginaries in there? No, so we're good. So yes, this is a polynomial. Do I need to change the order of anything to put it in standard? because standard just means descending. Nope, we're good. And so I want to look for, I'm going to state two things. I want to state the highest degree, which I'm going to denote as n. So degree, I'm going to use the letter n. So what's my highest exponent? 4. And then I want to write my leading coefficient. And I'm going to write that as a sub n. So what is the coefficient in front of x to the 4th? Just 1. Because if nothing's there, I'm just going to say 1.
It's just whatever the first coefficient.
Whatever number is in front of the highest exponent. Yes?
So you don't have to write, when n equals 4 or 3, you don't have to write 4 tick or anything?
Oh, it says state the type. Yeah, so you could say quartic. The only time you wouldn't want to write it is if it's higher than 4. Okay, let's look at number 2. Are all of my exponents real numbers? What do you think? So the first one is x to the first power. The second one is just a constant, so it's x to the 0. And then we have x squared. So all of my exponents are real numbers. Coefficients, are any of them imaginary? Well, the only thing that, if this were imaginary, it would have a negative in here. Like it would have a negative inside the square root. You can have a negative outside of the square root, so that's fine. So I don't have any imaginaries. You probably won't have any imaginaries. The second rule will almost always apply, unless you see an I in there, but I don't really see too many I's when I'm doing polynomials. So the next thing I want to do is put it in standard form because the two conditions check out. So if I want to put it in standard form, descending order, so I'm going to put the pi x squared first, plus 7x minus square root of 3. Then I want to name two things. So my highest degree, which I call n, is what? The coefficient in front of x squared is pi. And this is what type? Quadratic. Okay, number 3, my exponents. Are they all real integers or whole numbers? No, because of what? -1. So no, you can't have the negative exponents. They must all be positive real numbers. Okay, what about number 4? Is there an issue there? No. So no x's as an exponent. You don't want a variable. So exponents must be positive real numbers. Can't be variables. Can't be negatives. Number 5, what do you think about this one?
Yeah.
Yes. Because why? Right, it's just a constant. So you can have no x's in there and it still be a polynomial. Just means that it's a constant because my degree, n, would be what? 0. And my coefficient in front of that would just be -5. Okay, lastly, try number 6 on your own. So put it in standard form, state the degree, leading coefficient, and then the name for it. So for standard form, you should have gotten -3x cubed plus 5x plus 14. The highest degree is going to be 3. The leading coefficient is -3, and it was a cubic function. All right, looking at end behavior. So once we start graphing, there is a way to determine end behavior just based off of looking at the equation. So like on a quiz or a test, I could give you an equation, make it non-calculator, and say, what is the end behavior? So end behavior, all that that's asking is, what does it do to the left and what does it do to the right? So end behavior just means, what's the graph doing to the left? What is the graph doing to the right? Is it going up or down to the left? Is it going up or down to the right? And so we have these handy dandy arrows for you, but the way that I would want you to write it on a test, I'm gonna write it in a different format. So you do need to memorize these, so you might want to like make yourself a note, memorize. If you have a degree that is odd, so anything like x to the first power, x to the third power, x to the fifth power, anything like that, then, and your leading coefficient is positive. So if it fits both of those two conditions, you have, so an example could be 2x to the third, something like that. Your leading coefficient must be positive, and your degree must be odd. Then to the left, it's going to be going to negative infinity. To the right, it's going to be going to positive infinity. So I have these little arrows. They will always be going, anytime that you have an odd function, so x to the first, third, fifth, seventh, ninth, odd is always going to be going in opposite directions. So you might want to make yourself, I always tell myself odd equals opposite. Because this right here should say odd. I remember having that typo last year and I did not fix it. Shame on me.
What do you mean by odd is opposite?
Like your graph is going to be going opposite directions.
Oh, okay.
Yeah. They'll be pointing in different ways. So I always kind of think of this as like a little cheerleader move, like with my arms. Because if it's odd positive, it's going to be going down and then up. So I always think, like, to help myself memorize this, odd is opposite. So I think of it that way. Then positive means, like if it's positive, it's going to be going positive to the right. If it's negative, then it's going to be going negative to the right. So whatever my leading coefficient is what it's doing to the right. And then it's just doing the opposite in the other direction. How I would want you to write end behavior is, instead of the arrows, because arrows are for babies, we are in pre-AP Algebra 2, we can do this. What I would want you to say is as x goes to negative infinity. I'm going to rewrite that. So as x approaches negative infinity, which what that is saying right here is like to the left, because as my x values are going to the left, as x is going to negative infinity, f of x also goes to negative infinity. Does that kind of make sense? Like as my x values are going to the left, which is saying negative infinity, my y values, so f of x is y, same thing. Y is also going to negative infinity. So what would my end behavior statement be for the right? As x is what? So as x goes to positive infinity, f of x goes to what? Positive infinity.
Is that for the second one?
So that's what the right arrow is telling me. So try to write end behavior statements for the odd negative end behavior. These two will always be the same. As x goes to negative infinity, as x goes to positive infinity. Those don't change.
The bottom one is the same one?
This is all for this graph right here. because I'm writing like what happens to, so the top statement is telling me what happens to the left. The bottom statement is telling me what happens to the right. So you'll always have two of them for every graph. Because end behavior, you're telling me what happens to the left and to the right. So as x approaches negative infinity, as x approaches positive infinity. And you don't have to put the plus sign. I sometimes do. I'm not going to take off for it either way. So as x is going to the left, what is my graph doing? What is f of x doing? It's going up, so f of x goes to positive infinity. Like this. As x is going to the right, so as x is going to positive infinity, what is the y doing? It's going down, which means it's going to negative infinity. Good. Now, when you have even exponents like x squared, x to the fourth, x to the sixth, 8, 2, 4, 6, 8, then they're going to be going in the same direction. So even is same. So they're either going to be pointing up, touchdown, or they're going to be pointing down. And it's easy to know whether they're pointing up or down based on your leading coefficient. So positive means up, negative means down. But they're going in the same direction. So if I were to write in behavior statements for even positive, I would say as x approaches negative infinity, f of x does what? So to the left, it's going up, so positive infinity. And since they're the same, as x approaches positive infinity, f of x also approaches positive infinity. So what you have to do in your head, when you write these two things, this one is saying as x approaches negative infinity. Basically, in my head, I'm thinking to the left. That's all. That's just a fancy way to write to the left. To the left, it goes up. So that's what f of x goes to positive infinity. That's just saying up. So in my head, I'm thinking left, up, right, up. But the way that I wrote it is just a fancy way to say that. Okay? So for the last one, same thing as x approaches negative infinity. F of x approaches what? It's going down, so negative infinity. As x approaches positive infinity, so to the right, f of x also goes down, so f of x goes to negative infinity. Looking at 7 and 8, it says what is the degree, what is the leading coefficient, and what is the end behavior. So the only thing I need to look at is my highest degree. I can ignore everything else. So my highest degree in number 7 is what? 4. So I'm gonna circle this right here, negative x to the 4th. My degree, so n equals 4. My leading coefficient is what? Negative 1. So 4 is a positive or negative number, or no, I'm sorry, odd or even number. Even. And my leading coefficient is positive or negative. So even, negative. Even means they're going to be going in the same direction. Negative means they're both going to be pointing down. So in my head, if I want to draw my arrows, they're both going to be pointing down. But I want to write it in the fancy way. So as x approaches negative infinity, f of x approaches what? Infinity. As x approaches positive infinity, so to the right, f of x also goes down, so negative infinity. Okay, try number 8. Look at the highest degree, tell me what the leading coefficient is, and then describe the end behavior. Work. Okay, so my largest degree was 3. The leading coefficient is 1, so we have an odd positive. Odd means opposite, and since it's positive, that means to the right it's going to be positive. So then to the left it's going to be negative. So make my little arms like this. I don't know why, I just do the arms. Then my end behavior is x goes to the left, so as x approaches negative infinity, f of x also approaches negative infinity. As x approaches positive infinity, f of x approaches positive infinity. So to the left it goes down, to the right it goes up. Okay, for numbers 9 and 10, I'm going to give you a couple options of things you can do. You can use your calculator to graph. So if you have the Inspire, then you'll just go to the graphing function and type in this polynomial right here into the function. And I want you to find the y values for these specific x values. So -2. Remember that if you want to find the y values, if you just type them in and hit enter. So if you type in -2, enter, it's going to give you that ordered pair. -1, 0, 1, 2, and 3. But before we do that, I want us to determine the end behavior from the function. So looking at it, looking at the highest degree, what would that be? 3. So my n equals 3. My leading coefficient is -1. So we have an odd or even, and positive or negative? Negative. So I'm not going to make you write it out. Let's just do the arrows. Are they going to be going in the same direction or opposite directions? Opposite. What's it going to be doing to the left? It's going to be going up to the left and then down to the right. So it's going to be doing something like that. Up to the left, down to the right. Because when it's odd, whether it's positive or negative, if it's negative, that means that's what it's doing to the right. And it's doing the opposite to the left. So in your calculator, I want you to type in the function. Once you graph that function, I want you to find the y values. So once you have it graphed, if you just type in -2, enter, it's going to give you the y value for that. So I'm going to go ahead and write the y values that you should get. If you don't want to graph it in your calculator, then you can always plug them in. So you can plug in -2 into the function and then get a y value algebraically. So you can kind of see the reason why we're graphing this is just to show you how the end behavior works. So to the left, it's going up. To the right, it's going down. End behavior.
We need to graph it too.
Yeah, so plot your points whenever you're finished. Okay, if we look at number 10, before I even did anything, I've already filled it out, but before you even do anything, you can look at it and decide what the end behavior is. So x to the fourth is my highest degree. So n equals 4. What is my leading coefficient?
4.
So what's the number in front of the x to the fourth? Just 1. So then I've got an even, positive. Even means they're going to be doing what? Same direction. And positive means they're both going to be facing up. So makes like a big U, like this. Which, when you graph, they both are pointing upward. So you can just use graphing to check and see what the end behavior is doing. However, like if it were on a test or something, I wouldn't make you graph it without a calculator. But if it were a non-calculator portion, I would just give you the equation and ask you to find the end behavior.